Hello students, you are welcome. This is Madam Hawa in chemistry from 4, and our today's lesson will be isomerisms in alkanes. So I saw you are happy today to join this lesson. Before anything, my dear students, I want you to observe this structure carefully. Then I'm going to ask you a question. Look at this. Observe these carefully. Have you seen here? These are models of organic compounds. So I want you to observe how many atoms are in each of these compounds. Let us start. Yes? How many of these? Oh, 4. Thank you. And this one? 4. Okay, thank you. And this one? Oh, good. Therefore, when you are seeing here, we see that we have 3 organic compounds models of the same numbers of atoms. Therefore, this is what we call of these are isomers. What is meant by isomers? This word isomers is from a Greek term and composed of 2 words which are iso. The word iso from the Greek means same or equal. Then the next word or the second word is meso, and which means parts. Therefore, isomers in Greek means same parts. So over here we have these 3 compounds of the same number of atoms or same parts. So to get more concepts, I want you to observe again these carefully. Here, I have this one. I have this compound. How many atoms in this compound? How many are they? Yes, Ali? Good. They are 5. 1, 2, 3, 4. Sorry, there are 6, my dear. Okay, they are 6. 1, 2, 3, 4, 5, 6. In this compound, we have 6 atoms. So, let us look how many atoms, how many molecules can we get from the arrangement of this one molecule. Look at this one too. Look carefully. Here, there are 2 molecules again, or compounds. Let us count the number of atoms from each one. Let us start with this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good. Also, in these compounds, we have 6 atoms. Therefore, this one, and this one, we say they are the same. They are the same in terms of what? They are the same because they have the same number of atoms. All of them contain 6 atoms. So, let us look at another things. How these 6 atoms are arranged. Are they arranged the same? Those atoms arranged in the same way as this one? Of course, no. Here, we see that for this one, we have a linear one. we have a linear structure. And for this one, we have this kind of structure. Have you seen? And this one, okay. Therefore, we have observed that these three and these also three, they have the same number of atoms, but these atoms are arranged differently. Therefore, this arrangement gives us different structures. The same way as this one, 4 number of atoms, 4 number of atoms, and here also 4 numbers of atoms. But, what about the arrangement? It's different. Good. They arrange differently. So from here now, we can get the meaning of the word isomer. We say that these compounds are isomers of each other. And also, these three are isomers of each other. Why? This is because of the meaning of the isomers. Isomers, these are the compounds, right? By definition now, we can say isomers are the organic compounds, organic compounds which have the same what? Yes, good. Same molecular formula. This is what you have observed. They have the same molecular formula. But what are they different? But different what? Can you tell? Different what? Different, who can try? Yes. Amina? Thank you very much. Different structures, different structural formula. Yes, because all of these are the same, but they differ in structures. Therefore, they have the same molecular formula, but different structural formula. So this is what is meant by isomers. So from these, you may see that all of these are the isomers of each other, and these also are the isomers of each other. The reason behind is what? Yes, they have the same molecular formula. Because here, if you count, you may see number of atoms are the same as this one and this one. The same case in these three. There are the same number of atoms from each compound. But what is the difference is on the structural formula. The way these atoms are arranged in different ways. So, my dear students, now, after getting the concept about isomers, so now let us come in our target. Our target is isomerism in alkane. Isomerisms in alkane. So let us look how we obtain the isomers from alkane. Isomers in alkanes, for the first three compounds under these alkane groups have no isomers. They don't possess isomers. This is because, who can tell me? We have the first member of alkane is methane, good. The next one, the first member is methane, good. The second member is, yes, ethane. The third one is Propane. Okay, thank you. So isomerism, when you talk isomerism in alkane, these three members, they don't possess isomers. Can you tell me? Can you try to say something? Why? Why? Yes, Zubeda? Okay, thank you. You have tried. You have tried. This is because, my dear, this, whatever you're going to arrange the atoms in methane, you're not going to get the different structure. The same case in ethane. Whatever you're going to arrange the atoms within a methane, you're not going to have a different structure. You'll get the same structure. Therefore, this will not be an isomer. And also in propane, we can't get different structure by arranging the atoms within the propane. So now, let us look. Observe this one. Does it have isomers? Does it have isomers? The next, the next member after propane is what? Oh, good, is butane. So here, let us look on the isomers in butane. First, I want you to count this one. Butane, how many carbon atoms in butane? Okay. How many carbon atoms in butane? Let us count together. 1, 2, 3, 4. 4. There are 4 carbons in butane. And how many hydrogen? How many hydrogen? Let us count together again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. In butane, there are 4 carbons and 10 hydrogens, right? So let us look if we can change the structure, or we can obtain all the structure from this butane. So first, let us detach. Here we have an alkyl group. We have an alkyl group that is carbon with 3 hydrogen. So let us detach this compound, this alkyl group, and then let us to attach on the 3rd carbon. This was carbon number 1, number 2, number 3, number 4. So let us detach this group of alkyl group and attach to the carbon 3 here. And so this one here, remember there was a hydrogen here. There was a hydrogen here. So we detach this group, we detach this alkyl group, and we are going to attach it on this carbon number 3. So where this hydrogen will go? Therefore, this hydrogen will going to attach on the positions where there was this group, this one. So now, this will be the second compound, or the second structure from this one. The first one was the 4H10, which was linear. So we detach this alkyl group and attach to the carbon number 3, which is this one. So now we have this kind of structure. Have you seen? What about the arrangement? Are they arranged the same? Are they arranged the same? Yes, of course, no. They are of different arrangements. So now let us count about number of atoms present. Are they different or the same? Okay? Here, let us count on carbons. How many carbons? Let us count together, my dear students. 1, 2, 3, 4. Still, we have 4 carbons. Therefore, here also we have C4. What about hydrogen? What about hydrogen? Let us count together. Let us count. Here we have, how many hydrogen? How many hydrogen? Come on, come on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 again, my dear. Ha! Therefore, here we have also 10 hydrogen. Ha! It means we have what? We have what? Yes, we have the same number of atoms. We have the same number of atoms, but different what? Different structure. Thank you very much, my dear student. We have different structures. And this is what we call the isomers. Therefore, in butane here we have how many isomers? How many isomers? How many isomers? Yes, you have understood well. We have 2 isomers. This one, linear one, and this one is branched. But when we count here, we can see linear structure, and this one is with the branched. Therefore, they are arranged differently, but have the same what? Molecular formula. Thank you very much. So now, I want you to look for these 2 structures and give me the name. Let us start with this one. What is the name for this? Who is ready? Who is ready? Hamid, you are so quiet today. Tell me, what is the name for this? Thank you very much. It's butane. You are right, my dear. This is butane. This is butane. The IUPAC name for this compound is butane, while its common name we call normal butane or N-butane. Thank you. Now, the second structure. What is the name for this? What is the name for this? Yes, hyphen? Thank you very much. Clap for her. Good. This is 2-methylpropane. Therefore, 2-methylpropane and butane are the 2 possible isomers from the compound of butane, because these 2 structures are arranged differently. That is, they have different structures. But in terms of molecular formula, these 2 compounds contain the same number of atoms. Therefore, we conclude that these 2 are the isomers of each other. Thank you very much, my dear. So now I want you to look whether you have understood well. I want you to look for this structure carefully. Then I want you to draw or to tell me the possible isomers from this compound now. Wait for it. What is that compound? What is that compound? What is that compound? This one. This one. So, observe carefully. Observe carefully. This is pentane, my dear. This is pentane. Let us count number. Let us count number of atoms present. Let us start with carbon. How many carbons are there? Okay, 1, 2, 3, 4, 5. In this pentane, we have 5 carbon atoms. And how many hydrogens? How many hydrogens? Let us count together. 1, 2, 3. Here we have 5 carbon atoms. And hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. There are 12 hydrogen. This is pentane. So now I want you to draw out the possible isomers. What is the first? What is the first? Who can try? Which branch can we detach to attach somewhere so as to have another new structure? Who can try? Who is ready? Oh, yes, Bakari, Bakari. This one? Okay. Bakari said we have to detach this group. To where? To where? Okay, to detach this group. To where? Oh, to carbon number 4. Okay, this one. 1, 2, 3, 4. Okay, thank you very much, Bakari. You have understood. Bakari said we have to detach this methyl group and to attach to the carbon number 4. We are going to have another structure. Okay, let us do that. Let us do that to look whether we get the different structures or not. Let us look if Bakari is right or no. Let us look. Bakari said we have to detach this group and to attach to the carbon number 4. Therefore, okay, I detach it. This will be carbon number 4 from this structure. I attached here. Oh. And then to replace hydrogen. Hydrogen here will be removed. Like this. Now, let us count again to look whether Bakari is right or no. Remember that we have to go to what? Yes, we have to get same number of atoms, but arranged differently, okay? In case of arrangement, are they arranged equally? No, we have different structures. So for this case, Bakari now is right, because these two structures are of different arrangement. This is linear, this is with branched one. So what about number of atoms? Let us look if Bakari is right or wrong. Now let us count it together. Let us start with carbon. Okay? 1, 2, 3, 4, 5. There are 5 carbons. Okay? I'm going to write over here. C5. Okay? Bakari is approaching to get big right. Let us continue on the hydrogen. Let us count numbers of hydrogen. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Still we have 12 hydrogen. So I want a big clap to Bakari. Thank you very much. Bakari was right. Because here when we look on the arrangement of the atom, this and this arrange differently. And also the numbers of hydrogen and carbon, here we have 5 carbon atoms, here we have 5 carbon atoms. We have 12, and also here we have 12. Therefore, we have different structure, but same molecular formula. Therefore, these two are isomers of each other. Thank you very much. Is there any other possible isomer from this compound? Any other possible isomer? Safia say yes, yes, yes. Okay. Tell me, Safia. Tell me, Safia. What is the next isomer? Here? We remove here? Where? Oh, okay. He said that now we can remove over here. The same carbon. Okay. Now, let us look if Safia is right or wrong. Say that we have to remove. Safia now said we have to remove this group. To remove this group to attach to the same carbon. To remove this group to attach to the same carbon. Therefore, okay, if we remove this group, This one. Then, Sophia said we have to attach this one, this group, to the carbon number 3 from this one, from this structure. This is carbon 1, carbon 2, carbon 3, and carbon 4. So Sophia said we have to detach this group, alkyl group, to the carbon number 3, which is this one. So, and hydrogen will going to attach at this position where this alkyl group has been removed. Okay, here. This is the carbon with 1, 2, 3. This one, carbon, is this one. With the, how many hydrogens? 1, 2, 3. 1, 2, 3. Hydrogens are there. And this hydrogen now, from here, is taken out, of course, will be here. Here. This one. Already there. So now, let us look if Sophia have understood well on the concept of isomers by predicting this structure. Therefore, here, how many number of carbons? Let us count. 1, 2, 3, okay, 1, 2, 3, 4, 5. There are 5 carbon atoms. C5. What about hydrogen? Let us count number of hydrogen atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 hydrogen again. Thank you, my dear students. Clap 2 for Sophia. Thank you. What about these structures? Are they the same? Do the atoms within these compounds arranged in the same? Of course, no. We have this one linear one. We have this one with branch, only one branch. And here we have this one with 2 branches. Therefore, we can conclude that these 3 structures are the isomers for what? For pentane. So thank you very much, my dear students. You have understood well. So today we have learned about isomarism in alkane, in which we have said that the isomers does not, it is impossible to get isomers for the first 3 members of this group, that is methane, ethane, and propane. But we can get isomers from butane and pentane, in which we have got 2 isomers, 2 possible isomers from butane, that is butane and 2-methyl propane. And also we have 3 possible isomers from pentane, in which the first one is this one, the second one is this one, and the third one is this one. So after that, this will be your homework. I want you to go to do this at home. I want you to do this at home. I want you to write. The question is, give the IUPAC names of the following compounds. 1, 2, 3. So these are the isomers of each other. I want you to write their names. This will be your homework. Okay, thank you very much, my dear students, for your participation, and you have responded well to the lesson. I hope you have enjoyed the lesson. So, till next lesson, bye-bye.